Good morning, students. So, good morning. So, periodic classification of elements, right? So, that's what we were discussing about periodic classification of elements. Okay? Now, briefly, I will explain whatever we have discussed all these days. Since from 2 days we were going with Google Meet, right? And there were some problem. So, briefly I will explain. So, we have discussed about ionization enthalpy, that is nothing but delta IH. Then we have discussed about electron gain enthalpy. Then we have discussed about electron gain enthalpy. So that's where we have the symbol. So ionization enthalpy and electron gain enthalpy. Okay? Fine, these two concepts we have discussed. So now when it comes to ionization enthalpy and electron gain enthalpy, they are exactly opposite to each other. Okay, they are exactly opposite to each other, but both of them having common unit, that is kilojoules per mole, or we can write it as kilocalories per mole. It can be kilojoules per mole or kilocalories per mole. That will be the common unit, but for both of them. Now when I am talking about ionization enthalpy, so what will happen here? We have an atom, okay? So where electrons will be removed and it will become X plus. It will become X plus. That means we are removing the electron from a neutral atom under its gaseous condition, when it is in the gaseous condition. So that's what we are doing for ionization enthalpy. So what we are going to do with electron gain enthalpy? Where once again we have an atom, but where we are adding the electron and it will become negatively charged ion. It will become negatively charged ion. That's why I told both of them, they are exactly opposite to each other. Yes, good morning to everyone. Okay, so come fast. So that's why we have ionization enthalpy, and that's why we have electron gain enthalpy. So in ionization enthalpy, we are removing the electron and we are getting cation. In case of the electron gain enthalpy, we are adding the electron and we are getting anions. Okay, so in both the cases, either there will be utilization of energy or there will be release of energy. So in this case, there will be utilization of energy, where in ionization enthalpy, because we are taking away the negatively charged electron from the nucleus, that is positively charged. But when it comes to electron gain enthalpy, there will be release of energy. All of you got my point? So in one case there will be utilization of energy. In another case there will be release of energy. Okay? So that's what we can see when it comes to ionization enthalpy and electron gain enthalpy. Okay, so in ionization enthalpy there will be utilization of energy. Since there is a utilization of energy, it will be having positive values. Value might be different, but value will be a positive value. Okay, so that's what with respect to ionization enthalpy. So this is one point. This is another point, this is another point. So here also, when it comes to values, it will have the negative values, except inert gas, except inert gases, which will be having positive values. Whether I am clear? In case of the electron gain enthalpy, negative values will be there except for inert gases. Okay? So that's what we can see, ionization enthalpy and electron gain enthalpy. All of you have understood? Now I can define. When I am talking about ionization enthalpy, it is the change in the enthalpy. It is the change in the enthalpy when an electron, outermost electron, is removed from a neutral atom in its ground state. What do you mean by ionization enthalpy? It is the change in enthalpy when outermost electron from a neutral atom in its ground state will be removed. Or we can tell that it is the amount of energy which will be required to remove the electron from a neutral atom in its ground state. That is one thing. So when it comes to electron gain enthalpy, it is the change in the enthalpy. It is the change in the enthalpy when a neutral element in its ground state is added with the electron. It is added with the electron. That's where we have the electron gain enthalpy. Or it is the amount of energy released when a neutral atom is going to take up the electron. Okay, so here energy utilized, here energy released. But only thing here is for inert gases, we have to apply the energy to add the electron. So now all of us, people had given the answer yesterday. Yes, why inert gas? Exceptional cases. That is because they have already with octet state. They are already in their octet state. They are having stable electronic configuration. So therefore they don't want to have other extra electrons. So therefore it demands the energy to add the electron to the inert gases. Right? So that's what we have discussed. Yes, Rohan. They have the octet structure. All of you have understood these two concepts? Okay? Then we have discussed with ionization enthalpy, we have discussed about some exceptional cases like nitrogen, oxygen, beryllium and boron. Okay? So shall I remove this? Then we will go to the next one. Okay? So we will move to the next one. Now when we are talking about the next concept, which is also very important, please remember in your examination any of these they can ask. So if they are asking this one, then you should first define what you mean by that particular terminology. Then you should talk about how elements are distributed based on these properties. Okay? So next one is also very important. Okay, so that is electronegativity. That is electronegativity. Okay, that is electronegativity. Okay, yes, Dikshit, good morning. So good morning to everyone. So electronegativity. When I am talking about electronegativity, it is a qualitative measurement. It is a qualitative measurement. Okay, so it's a qualitative measurement. When I am talking about qualitative, we have two types, quantitative, qualitative. So qualitative means we are having some approximate values. Okay, we are not very sure that is the exact value. What I mean to tell here is it's not an exact value, it's a qualitative. Okay, say for example I have a rice. Now I can tell that in the rice we have the carbohydrate, one of the molecule. Biology students will be knowing. So we have the rice. In that we know that carbohydrates will be there. So that is a qualitative statement. That is a qualitative statement where I am telling that rice is having carbohydrate. Now, I will tell that rice is having 45 grams per kg. 45 grams or 400 grams per kg. Rice is having 400 grams per kg of carbohydrate. Now I am specifying the values. Now I am specifying the values. That means it is a quantitative. Now you got the point, the difference between qualitative and quantitative. Okay. So quantitative means where I am talking about exact values, exact concentration. But qualitative means I am not bothered about the values. I am just telling whether it is there or not. Okay. Yes, children. So that's where electronegativity is a qualitative measurement. It's not like electron gain enthalpy where we will be having some negative values. When it comes to ionization enthalpy where we have some positive values, we have the values. But here it's a qualitative measurement. So please remember, electronegativity does not have no SI units. No SI units. Okay. See, for example, whatever we have discussed, if you talk about atomic size, we have the unit. It can be picometer, nanometer, angstrom, which are derived from the meter itself. That can be the unit for the atomic size. When it comes to ionization enthalpy and electron gain enthalpy, it was kilojoules or kilocalories per mole. But here we don't have any SI unit. That was one of the question in one of the competitive exams. Which one I have forgotten? It was there. They had asked that among the following, which does not have the unit, and they had given different properties. Okay, and proper answer should be electronegativity. Okay, all of you have understood. So that's where we have the electronegativity. What do you mean by electronegativity? So what do you mean by electronegativity? Now we have to define. Okay. Now I can tell that it is the ability. It is the ability of a element. It is the ability of an element to attract the electron. Rohan, not tendency to lose an electron. No. Okay. It is the ability of an element to attract the electron. When or in a compound. In its compound. That is better word. To attract the electron in its compound. To attract the electron in its covalent compounds. Okay. So that's where we have the electronegativity. So I am specifying the value as compound. So what do you mean by compound? Compounds are those molecules which are made up of more than one type of element. Right? Say for example, I have nitrogen, I have oxygen, I have chlorine. All these, they are molecules, no doubt. They are molecules, but not compounds. All of you will agree? They are all molecules, but not compounds. Which one? Nitrogen, oxygen, chlorine molecules. Okay, I am not talking about the atom. N2, O2, Cl2. That means 2 nitrogen, 2 oxygen, 2 chlorine. Now they are no more atoms. They are molecules. Okay. So yes, Dikshit. So compounds are those which will be having different elements like water, like glucose. Okay. So or I can talk about many other compounds where more than one type of elements are involved. Now, electronegativity, it deals with the compounds, not with the molecules. Because in the molecules, since same type of elements will be there, they will be equally potent. If I take nitrogen molecule, Both are nitrogen. No one can beat the other because they are same element. If I take oxygen molecule O2, both are oxygen, both will be of same element, so no one will dominate with the others. So therefore, it is applicable for the compound. Electronegativity is applicable for the compound. Okay? So all of you have understood this particular statement. It is the ability of an element to attract the electron towards itself in a compound. Okay, say for example, if I take water, I have oxygen, hydrogen, hydrogen, right? So why it will be having band structure? We are going to study all these things in chemical bonding. Don't worry about that. But for time being, you observe about the element. Generally, we are going to talk about water molecule like this. We are going to write the structure of water molecule like this, H2O. Okay? Now, there is a presence of covalent bond. There is a presence of covalent bond. Okay, once again, with regard to the covalent bond, we are going to discuss in your chemical bonding. Don't worry. Now, I can tell that these lines where it talks about the electron, these lines they talks about the sharing of electrons. Okay, listen to me carefully. These lines they talks about sharing of the electron. So hydrogen 1 electron, oxygen 1 electron, oxygen 1 electron, hydrogen 1 electron. So that's what it talks about. Okay. Now, in reality, here it looks like this electron near to hydrogen, this electron near to the oxygen, this electron near to hydrogen, this electron near to oxygen. It looks like that. But in reality, what will happen here is, so what is happening? It is just to make you understand I am writing. So what is happening? Now I can see that whatever two electron, even the electron which belongs to hydrogen, it has been pulled near to the oxygen. An electron which belongs to hydrogen, it has been pulled near to the oxygen. Right? So what I need to tell here is, in a compound, as a water molecule is a compound, near the oxygen we have higher electron density, which we will mention it as delta negative. Okay, anyway, delta negative, delta positive, it comes under dipole moment, which we are going to study in chemical bonding. But for time being, you should understand that why I have mentioned delta negative, because in a compound, I can see that electron density is more near to the oxygen compared to these two hydrogen. Okay, so therefore I will mention them as delta positive, delta positive, since electron density is less near to the hydrogen. Now this is because oxygen is more or highly electronegative compared to hydrogen. Okay, so oxygen is highly electronegative compared to these two hydrogen. So therefore they are attracting the electron. They are making electrons to move away from the hydrogen. So listen to me carefully, there is a difference. I am not telling that oxygen is gaining the electron. Gaining or taking and attracting. Okay? So try to understand this terminology. So when I am talking about gaining or taking, it is nothing but accepting the electron completely. Accepting the electron completely. But when I am telling attracting, it is just attracting. Okay, it's just attraction which is happening. So that's where we have the electronegativity, which talks about attracting of the electron. If I talk about gaining, then I am not dealing with electronegativity, I am talking about electron gain enthalpy. Whether all of you have understood? Any doubts? All of you have understood? Okay? Okay, fine. So that's where we have the electronegativity. That's where we have the electronegativity. Okay? Now, we have a scale. It is a scale without any SI unit. Once again, we have a scale which is called as Pauling scale. Okay, we have a scale which is called as Pauling scale, which was forwarded by Pauling. That's why they have kept the name it as Pauling scale. Okay, so which talks about electronegativity, which has given some values, approximate values. Okay, so that is called as Pauling scale. Okay, now here he has given different values. He has given different values. Say for example, I have fluorine. I have the fluorine. Electronegativity of fluorine is value is 4. Electronegativity value for fluorine according to Pauling scale is 4. If I take chlorine, it is somewhere around 3.5 to 3. Okay, somewhere in between 3.3 to 3.5. So if I take oxygen, it will be 3.5. So it will be 3.5. So if I take nitrogen, sorry, if I take nitrogen, it will be somewhere around 3 to 3.5. I am talking about approximate values. Okay, so what I mean to tell here is, when I am talking about halogens, we know that halogens are the one which will become negatively charged in the nature. Bromide. Iodine is becoming iodide. Like that, we have the halogens which will become negatively charged. Okay, and we know that in periodic table halogens will be considered as electronegative element because they are of smallest atomic size. But here even oxygen and nitrogen, they are dominating with respect to electronegativity. Because even they are of smaller atomic size. In their respective group, oxygen and nitrogen are the one which occupies the first position. Okay, so that's where we have the electronegativity. Got my point? So please remember, in the periodic table, highly electronegative element is fluorine. It is a big boss. When fluorine comes, all the other elements, they have to take out the electron and they have to push the electron towards the fluorine. They have to accept. Whenever fluorine comes, ಮೈಸೂರು ಭಾಷೆಯಲ್ಲಿ ಹೇಳಬೇಕು ಅಂದರೆ ಹ್ಞೂ ಅಣ್ಣ ತಗೊಳ್ಳೋಣ ಅಣ್ಣ ನಿಂದೆ ಅಣ್ಣ ಇದು ಎಲೆಕ್ಟ್ರಾನ್ ನಿಂದೆ ಅಣ್ಣ. What my point? That's what in Mysore language. So that's where fluorine, when it comes, it's like a big boss. Everyone has to give the electron to the fluorine without any question. Okay? But when it comes to next element, it's not the chlorine. Next element is actually oxygen. Which can be electronegative. After oxygen, we can have either chlorine or nitrogen. Okay? So these are the 4 elements which will be considered as big boss. among the electronegative elements. And fluorine is once again big boss among the bosses. Okay? Okay. So Shukita, this values has been given based on their attraction of the electron. That's all. So maximum value they have considered 4 and based on that they have calculated for the others. Okay. But you remember about the Pauling scale and these values. Don't worry about how it has come, which you are going to study if you are going for higher studies. Okay. But for timing you consider that this is the highest value and all the other elements will have the values below 4. They will have the values below 4. Okay. So all of you have understood? Done? Actually it is a good question, but anyway, when you go for higher studies you will understand, but for time being you should understand that we have different scale, not only Pauling scale. We have different scale where they have been given different way to calculate the electronegativity. Okay? Fine. So that's where we have the electronegativity. If you observe it carefully, even my students, you people have not asked me, sir, you have not explained with respect to ionization and enthalpy, you have explained, but with respect to electron gain enthalpy, how elements are distributed in the periodic table, you have not explained, sir. You people have not asked me. So that one I kept it reserved because now I will use the information. Okay? Now listen to me carefully, because now what I will do is I will explain some points which I have already explained in earlier classes. Now still I will be explaining that one, and at the end I am going to talk about how the elements with respect to electronegativity, with respect to ionization enthalpy, and with respect to electron gain enthalpy, how they will be distributed. Okay? Now, as we know, down the group we have atoms which are going to increase their size. Okay? Which are going to increase their size. So this is down the group. This is down the group. This is all of us, we have studied all these things. Now, across the period, now what is happening? Atomic size is going to decrease. Right? Atomic size is going to decrease. But please remember, in each group, first element will be the smallest one. All of you will agree? In each respective group, first element will be the smallest element in that particular group. Okay? So we are not going to consider inert gas. That's what I told. When it comes to the atomic size, we are not going to consider the inert gas, because inert gases, they are monoatomic in nature. They are monoatomic in nature. So where we are not going to consider the atomic size of inert gas, and we are not going to compare that one with the other elements. Okay? So I am stopping. Imagine that this is group 17 element, that is halogens will be the last one. Across the period, electron gain enthalpy increases and down the group decreases. Yes, Stefan. Okay? Now according to this, observe here carefully. Already this one I have told, ionization enthalpy and atomic size, they are inversely related to each other. Ionization enthalpy and atomic size, they are inversely related to each other. If that is the case, what about electron gain enthalpy? Eg. Think that Eg is electron gain enthalpy. What will be the relation between electron gain enthalpy and atomic size? Any one of you, whether they are inversely related? Electron gain, enthalpy and atomic size, whether they are inversely related or directly related? Okay, Rohan is telling directly, Stephen is telling inversely. Okay, fine. But overall, if you see, they are also inversely related. They are also inversely related because as the atomic size decreases, electrons will be taken easily. Observe here, Gautam, Rakesh, observe here. Overall, if you see, they should be inversely related because whenever there is a decrease in the atomic size, more energy will be released. More energy will be released. Right? So, whenever down the group electron is added, less energy will be released. Less energy will be released. Okay? Shashank, it cannot be directly, it should be inversely, overall if you see. Because as there is a decrease in the atomic size, say for example, I have two atoms. This is one atom, this is another atom. Okay? I have the two atoms. Okay? I have the two atoms. Now, all of us we know that in the nucleus we have the positivity. Okay? Now, if I talk about electron gain enthalpy, that means where I will be adding the electron and during that time there will be release of energy. So, where I am adding the electron, during that time there will be release of energy. Okay? So, this is X element, this is Y element. So, biology students can consider chromosomes, XY chromosomes. Okay? Simply I am making a joke. So, I have X element and I have Y element. So, now I am adding the electron, some energy will be released. Now, I am adding the electron, some energy will be released. Now, where do you think electron will be much more easily taken by the nucleus? Among these two, where electron will be easily taken by the nucleus? Can you tell me? Which atom is going to take up the electron easily among X and Y? Just you can mention X or Y. Okay, according to Shashank, Y is going to take up the electron easily. All of you will agree with that? According to Shashank, Y is going to take up the electron easily. Shuchita is giving X. Shubhangi, she is telling Y. Okay, contradictory statements are coming. Okay, X, Y, Y, X. Okay, done. Now, okay, don't worry, I will take the example. Imagine that whatever I am holding a blue color pen, imagine that this is a magnet. This is a magnet. And this is the iron nail. This is the iron nail. This is magnet. This is the iron nail. First, please observe here carefully. This is the distance between iron nail and the magnet in the first case. This is the distance between the iron nail and the magnet. Now I will leave the magnet. Iron nail will equivalent attached to the magnet surface. Once again I will tell. This is iron nail. This is the distance between iron nail and the magnet. Okay. Now I am going to leave the iron nail. Now I am holding the iron nail, right? Now I am going to leave the iron nail. Immediately it will go and attach to the magnet surface. That is one thing. Now in second case, I have the iron nail and I have the iron nail. I have magnet and I have the iron nail. Now if I leave the iron nail, now it will go and it will attach to the magnet surface. There is a chance. When I am holding the iron nail such a far distance, it can go to the magnet or it can be bit attracted towards the magnet. There is a chance. But we will imagine it will go and it will attach to the magnet. Now, First condition, this is the distance. Second condition, this is the distance. First condition, this is the distance. Second condition, this is the distance. Now can you tell me whether in first condition iron nail was with high force towards the magnet, or in the second case iron nail was with highest force towards the magnet? Yes, Dikshit, any one of you. Just mention first or second. First case, this is the distance. Second case, this is distance. In which case iron nail will be with highest speed, it will move towards the magnet. First one or second one? Yes, Dikshit, it should be first condition because they are very close. Immediately, with higher rate, it will go and attach to the magnet surface. Same logic should be applicable here. Okay, same logic should be applicable here. When I am adding the electron to the atom. Yes, all of you are right. See, you are understanding iron nail and magnet because in day-to-day life, we have observed that one. As a student, when you people were in high school and all, people have studied about magnetic field in briefly. 10th and all people have studied, right? So that one you are understanding because you have seen that one. But you have to apply the same logic here also. Consider this one as a magnet. Please, it's not a magnet, but you should consider this one as a magnet, and this electron which I am adding, consider that one as an iron nail. Now, this is the outermost shell. I am adding the electron to this outermost shell. This is the outermost shell. I am adding electron to this one. Now, if you observe here carefully, the distance between outermost shell and the nucleus is this much. Here it is this much. Now we can easily tell that here distance is less, here distance is more. So therefore, electron will be taken easily by this particular atom because outermost energy level and the nucleus distance is less. Here electron will be taken, but not so easily as this one because the distance is bit high. Okay? So therefore, as the atomic size increases, listen to me carefully, as the atomic size increases, less energy will be released. As the atomic size increases, less energy will be released. That means change in electron gain enthalpy will be less. As the atomic size decreases, more energy will be released. That means change in enthalpy will be high. So therefore, I have mentioned like this. Okay, all of you have understood? So they are inversely related. Ionization enthalpy and electron gain enthalpy both are inversely related because as the atomic size increases, electron gaining will be difficult. As the atomic size increases, ionization enthalpy will increase. Okay, so that's where we have the relation. Okay, they are opposite. Ionization enthalpy and electron gain enthalpy, they are opposite, no doubt, but both are inversely related to atomic size. Okay, all of you have understood? So therefore, across the period, electron gain enthalpy is going to increase. Ionization enthalpy is going to decrease. Okay? Ionization enthalpy is also going to increase because more energy required. Okay? Down the group, ionization enthalpy is going to decrease. Even electron gaining will also become decrease. Okay? So that's where we have ionization enthalpy and electron gain enthalpy, which are inversely related to each other. Okay? Because in one case there is a utilization of energy, but in another case there is a release of energy. In the definition they are exactly opposite, but when it comes to their relation with atomic size, they are same. Okay? So any doubts? Any doubts in this? Please remember all these things, okay? So, hagadre, when I am talking about electronegativity, what will happen? What is the relation between atomic size and electronegativity? What will be the relation between atomic size and electronegativity? Any one of you? You can just mention inversely or directly. You can talk about electronegativity now. What is that relation? I will mention that one as En. What is the relation between electronegativity and atomic size? Yes, very good. They are also inversely related. So 1 by atomic size. What is the reason? That is because as the atomic size decreases, electronegativity is going to increase. As the atomic size increases, electronegativity is going to decrease. All of you are right. They are also inversely related. So therefore, all the three together, I will write it here. So therefore, across the period, due to decrease in the atomic size, okay, due to decrease in the atomic size, there will be increasing in the ionization enthalpy. That means more energy is required to remove the electron, or there will be more energy released. That means there is an increasing in the electron gain enthalpy negative value. There will be increasing in the electron gain enthalpy negative value. Okay, or simply you can mention it as there is an increasing in the electron gain enthalpy because more energy will be released, more negative value. Okay, so there is an increase in the electron gain enthalpy negative value, then there will be increasing in the electronegativity. Try to understand this. Okay, now therefore down the group due to increase in the atomic size, now everything will become reverse. So there is a decrease in the ionization enthalpy, there is a decrease in electron gain enthalpy negative value, and there is a decrease in the electronegativity. Okay? So all of you have understood? Any doubt in this? You can make this rough diagram in your notebook so that when you glance it, you can understand. Okay, don't by heart anything. So therefore I told everything depends on the atomic size. Okay? Fine? Okay. So shall I remove this? Whatever statement I have made, I will keep this one here only. I will remove this one. Okay na? So one point you should remember, as we have for ionization enthalpy, there are some exceptional case. Same is there for even electron gain enthalpy also. When it comes to electron gain enthalpy, once again we have the exceptional case. Okay? See, for example, I have fluorine, and fluorine is the big boss with respect to electronegativity. All of you will agree? Fluorine is having highest electronegativity value, that is fluorine. Okay? But when I am talking about electron gain enthalpy, chlorine is going to dominate. Highest negative electron gain enthalpy value. Highest negative electron gain enthalpy value. Try to understand this statement. So fluorine is having highest electronegative value in the periodic table, no doubt. But when it comes to electron gain enthalpy value, chlorine is the one which is having highest negative electron gain enthalpy value, not fluorine. It's not fluorine. So in that case, what might be the reason? Why this statement is there? How come, although fluorine is smallest atom, which should take up the electron easily, but still it is the chlorine which is dominating. Even chlorine will dominate over it with respect to oxygen also. What might be the reason? Any one of you? Okay, I will draw the picture, then you can understand. I have fluorine, period number 2, first energy level, second energy level. First energy level they are having 2 electrons. Second energy level they are having 3, 4, 5, 6, 7 electrons with respect to the fluorine. When I am talking about chlorine, once again we have energy level 1, energy level 2 and energy level 3. Because period number 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now outermost will have 7 electrons. 1, 2, 3, 4, 5, 6, 7. Okay? So both of them they are having 7 electrons. Rohan, I will come to that. When it comes to chlorine, it is having highest negative electron gain enthalpy value. That means chlorine is the good acceptor of electron. Although fluorine is more efficient in attracting the electron, but when it comes to the gaining, chlorine is going to dominate. Okay? So that's what. What is the reason? Although fluorine is highly efficient in attracting the electron, but still it will not take up the electron in its shell. What is the reason? No, Stefan. I will come to that. The answer is, this is because due to the smallest atomic size, and lack of space and electron repulsion, fluorine will have less electron gain enthalpy negative value compared to chlorine. So what is that answer? Due to the smallest size and due to which there will be lack of space or lack of place, and due to that electron repulsion will occur. So therefore fluorine will have less tendency to accept the electron. It will attract the electron, but it's not going to gain the electron. Okay? All of you have understood? Manish, what is that tiffin items? Okay? So all of you have understood? See, it's very simple logic. How many electrons are there? 7 electrons are there. All the elements they want to have the 8 electrons. Okay? All the elements they want to have the 8 electrons. So therefore, when another 1 electron will come here, so these electrons will be repelling those incoming electrons. But here, since there is some space available, so they will readjust themselves so that another electron can be accommodated. Okay, another electron can be accommodated. So that's where we have the fluorine and chlorine. Okay, so that's where we have the fluorine and chlorine. Any doubts? Manish, okay, you are not understanding. So here, since there is a small atomic size, only energy level 2 is available. It's like I have a bench where 3 students can be accommodated because that bench capacity is that much. It can accommodate only 3 students. Now if another student wants to sit over there, so what will happen? Whoever is occupying that particular bench, they are going to resist. Okay? So, but in case of a bench where 4 students can be accommodated, but only 3 students are there. Now, if someone comes and he will ask or she will ask, let me sit or let me occupy this space, then naturally other students will adjust themselves and that student can occupy the same bench. So, that's where we have the size of the energy level is going to matter. Okay? So therefore, due to the smallest atomic size, which has made fluorine highly electronegative element, and the same thing has made fluorine not to have the electrons. Okay. Okay, Manish. But try to understand these things. Okay, they are all very important. Okay. So that's where we have the fluorine and chlorine. Fine. All of you have understood? So please remember all these three. Individually also they can ask. Explain the distribution of elements with respect to ionization enthalpy. Same way, explain the distribution of elements with respect to electron gain enthalpy, or explain the distribution of elements with respect to electronegativity in the periodic table. Then first you should define what you mean by these concepts. For example, what you mean by electronegativity or what you mean by electron gain enthalpy. First you should explain. Then you should talk about their distribution and their relation with respect to atomic size. Okay? Then only you are going to get 3 or 4 marks. Normally it will be asked for 2 to 3 marks. Okay? So then you are going to get the complete marks. Saku class end ಮಾಡಿ sir. No. Still my time is there. Okay na? So any doubts? Last 2 minutes. Don't worry, last 2 minutes. Okay? Now I have metals and non-metals. I have metals and non-metals. Okay? Now I have metals and non-metals. Now that's where we have the metals, which are very good. Or in your high school you have studied about metals are those which will be having colors. Metals are those which will be shining, like that, and all explanation you have studied, which are malleable and ductile, everything you have studied. Okay? But now I will tell that metals are having one good character, that they are very good donors of electron. They are very good donors of electron. That's where we have the metals. Okay? So when I am talking about the non-metals, so that's where they are very good acceptors of the electron. They are very good acceptors of the electron. Non-metals. Okay? That's where we have the metals and non-metals. So where metals are donors of electron and non-metals are acceptors of electrons. Okay? So that means, say for example, if I take sodium chloride. Sodium chloride can easily donate the electron. That's where it will become Na plus, and Cl, which will take up this electron and it will become Cl minus. So that's where now I can tell that chlorine is accepting the electron, sodium is donating the electron. Got my point? So based on that, now I can tell that that's where we have sodium, which is called as alkali metal. Okay? And chlorine can be considered as a non-metal. Chlorine can be considered as a non-metal. All of you have understood? So that's where we have the concept, metals and non-metals. Anyway, we are going to discuss these things. We are going to discuss these things in the next class. Okay na? Fine. Manish and spherical gaming. Please, I can understand, but try to concentrate on the topics. I know since it is an online class, or I may not be reaching you people, but if you have any doubts, always you are welcome, but don't neglect the subject. Okay? So this is the PUC. I am not telling that you are not going to have good score in PUC, you are not going to survive. It will be there, no doubt. All of us, we are going to survive. We will be successful. But if you focus in PUC, you will become a successful person very early. Okay? So try to concentrate on the topic. If I am not able to reach you people, please let me know. Okay? So Manish or spherical gaming, I don't know who is spherical gaming. Okay na? So I know 1 hour you might be feeling bored, but try to focus. That's what my request will be. Okay na? So thank you. Thank you. Bye. Okay na? So Dikshit, bye. Okay. Thank you. Thank you everyone. Take care.